This problem I'm going to derive the overall expression for thermal resistance through a pipe R1 with radius 1 wrapped with insulation R2. So first I'm going to draw the pipe. With insulation wrapped around it. And this radius is R1. And then this radius is R2. So if we think about this pipe looking at it from the side, it would look something like this. With radius R1 and radius R2. So the heat transfer through this is through convection. And then this is convection. Yeah, so first is through conduction and the second is through convection. So if we think about these equations through conduction, we recall that heat flow is equal to the heat transfer coefficient times the area times delta T. And we can rewrite this as in the form of voltage is IR. So delta T is equal to Q HA. And through convection, we are just going to use this from before. Which is this. And if we think about, this would be Q times 1 over HA. This is R. So we think about series, we add the resistances. So R total is equal to this plus, I'm gonna rewrite it so it's smaller, matches ln R2 over R1, and that was K 2 pi H. And now, since these H's mean different things, this H is the heat transfer coefficient, and this H is the height of the, like, this is like area, so this is the height. So we're going to rewrite this. We're going to leave this H as the heat transfer coefficient, and area, we're going to calculate it's 2 pi R, and we're going to change the height to length. And then we're going to add this So ln R2 R1 K 2 pi, instead of height we're going to change into length. All right, so to find our total, to like find the max, we're going to take the derivative of our total. With respect to R2. So that's going to change this to that's going to change this to 1, negative 1, h 2 pi R2 squared L plus the R1, R2, and 1 over R1, and this is going to stay the same, 2 pi L. All right, so we're also going to set this equal to 0. So what is R2 when the resistance equals 0? So we're going to cancel out this. This is going to cancel out. We're going to cancel out this. So then that leaves this equal to 1 over h R2 squared plus equal to R2 over K, or I mean 1 over K R2, and then to solve for R2, that is R2 is equal to H over K. K over H. There we go. So in the previous part, I did part 1 and 2, determine the equations for the first and second overall derivative. Now I'm going to explain the consequences of why there's a minimum value of R2. So there's a minimum value for R2 because if there's too much area, if the area is greater than, or if R2 is large, then the area is greater than, the area gives you more thermoconvection because there's a greater area, there's more availability for area, or that more availability for heat transfer through convection. So there's like a balance. If you're spending more money on insulation, then the insulation can cause more heat transfer through convection. So there's a balance. You have to find the equilibrium. That's what K over H is for R2. So, yeah.